Hi, good morning. I'm so glad that everybody's able to join us for our AI and sustainability session here today. Just super excited to introduce this topic to the Dallas 2030 district, the members and the supporters of. It's we've gone through so many things in the last maybe 5 years or so. We're in a very new normal, and I know that AI has been around for quite some time, but it's become very popular in the last 5 years. So, I thought that what would be the best way to kind of introduce this topic of AI and how does it work with sustainability? How is it going to help us at the Dallas 2030 district get one step closer to our 2030 goals? So I'm really excited to head up this session. And I want to introduce Dr. Birchu. I'm going to actually let her introduce herself and, to start with the presentation. But before she does get started, um, I think that let's hold our questions till the end of the session because we do have time for Q&A. And if you'd like, you can put it into the chat as well, and we'll get to that towards the end. So, Dr. Bertu, I'm going to hand it over to you and you get us started.
Awesome. Thank you, Salima. And good morning, everybody. I know it's early morning from where you are, and I appreciate you joining the session. I'm excited to talk all our work and thoughts around, utilizing AI, mostly around operations and energy management side of things. As Salima said, my name is Burcu Akıncı. I'm a faculty member, also a department head in the Civil and Environmental Engineering Department at Carnegie Mellon. I'm also a co-founder and Chief Innovation Officer of LeanFM Technologies. I'm mentioning that because some of the slides are, some slides are research, some slides are from the startup, so you can see the kind of transitioning of research towards utilization. I do want this to be, I'm hoping that you'll ask questions at the end or toward, you can write your questions along the way. Looking forward to hearing your thoughts about this. We're all kind of figuring it out how to best use AI for our operations. So I'm going to start with, so I heard Salima said that this is the first of maybe several series of speakers you might have on this topic. So I thought I'll start with, laying the foundation, why AI and what is AI and why we're talking about this right now, why this is like an interesting time to talk about AI. So I'm going to bear with me going through a few slides on talking about, what is artificial intelligence. It's not a new concept, but why this is the time to talk about it. So, this is a definition. Basically, artificial intelligence refers to any kind a way to have computer systems capable of performing complex human tasks, right? And this involves, reasoning, making decisions, solving problems. In robotics, actually acting, right, doing things to fix the problems. And it has been around for decades. Actually, it's been around from 1960s, 70s, and it comes in waves as we go forward. And each wave had a high point, and then there were limitations that were discovered, and then it kind of moved to the second wave. So I'm going to talk a little bit about the historical perspective on AI, because you're going to see some of the previous AI implementations in the industry as well. So in 70s, 80s, 90s, during that time, the AI boom was all about expert systems. So expert systems in that case was, I'm going to capture an expert's knowledge in a bunch of if-then statements, right? If this happens, fix this. If this happens, do that type of thing. So there were quite a bit of systems, which we call as rule-based systems, that were developed during that time. We still have quite a bit of rule-based systems in the industry right now, where the idea is to capture that knowledge and then codify it and then use that. It's easy to implement, right? If I can capture that knowledge, I can easily implement these if-then statements. It's good, and it's a good way to do it. The problem, soon enough, right? Once we all, I was from that era too. I did a bunch of expert systems during my PhD. So when the problem there is that, you are limited to the knowledge of the person, and it's not easily scalable, right? So those if-then statements, you have to tailor it for each building in each different conditions. So there we refer to them as being very brittle and not scalable. So with that, that first AI wave kind of disappeared because people said, well, what good is this? It only works on specific things and nothing else. So the second wave came around, early 2000s with, now we have access to lots of data, lots and lots and lots of data around, either from sensors, World Wide Web and all of these. And this is kind of the machine learning. You might have also heard the term machine learning, which is, I would call it as like really advanced statistical models, right? So you will hear deep learning, neural networks. This is great. This was great because now you weren't relying on the expert's knowledge. So you are now looking at the data. You have labeled data that said, oh, this is when a break occurred. This is what happens. And then the system kind of trains itself and learns from it and identifies like the patterns of issues, and then, sends you an alert that says that, oh, I see a pattern of issue here, right? And this worked also really well, and it still continues. There's a lot of work around machine learning and deep learning, but the challenge there is that it's basically, as long as the history repeats itself, it's great, right? So we know, and as long as we have labeled data, we learn from it. So if we have good data sets that are labeled, and if history repeats itself, then it learns from the history and projects and says, okay, here are the things that I learned, and here's what I expect to happen. But in many cases, in our buildings, we have 100-year-old buildings. It's difficult to kind of say that history is going to continue to repeat itself, right? Because it changes all the time. So then there's this, what's called the contextual AI, or what, in our department, we utilize, digital twins plus AI, where now the AI systems are not learning just from the history, but also learning from the simulations and what could all the possible scenarios might be in the future, and then predict to the future accordingly. And then, we are also, I would say, in the middle of this fourth wave, right? So far we're doing mostly predictions, but now fourth wave is all about autonomy, right? So these agents become autonomous. They become our apprentice, right? So we talk to them, we ask questions, we get answers. We don't need to know all the algorithms behind it. So that's kind of more like human-like learning, human-like behavior, autonomy, interactive nature. So that's kind of where we are right now. So why now? With this fourth wave, right, with this notion of generative AI, large language models, there was I would say, breakthrough a couple years ago around this ChatGPT kind of notion. And you can see the two things. So one is that on the left, this is a few years old, but at least gives you the story, certain technologies, right? Netflix, Dropbox, Spotify, Twitter, how long it take them to reach the 1 millionth user. And you can see Netflix, it took 3.5 years to have 1 million users. Instagram, 2.5 months. Spotify, 5 months. And ChatGPT, in 5 days, it reached 1 million users, right? So what does that mean? That means that now we have a tool that is easy to use and that kind of eliminates the barrier around, oh my God, I don't know AI. It's too complicated. I can't understand. So now we can talk, right? We can write stuff and then it responds as we understand, and it works very well. So that's one kind of data that shows how fast we are all, right, adapting AI to everything we do. And then there's all sorts of course, work around, assessment around how smart is ChatGPT. And again, this is an earlier version of ChatGPT, but they ask, basically ChatGPT took SATs, calculus exams, math exams, and did fairly well, passing grade for most of them. I know that there was also a study where it took the our EIT, FE exam, right? And it passed. So that also tells us that, the results are good enough, right? It's not maybe perfect, but it's good enough to create, first set of solutions for us. We can rely on this agent. Uh, of course, not just, let them loose, but rely on that as we rely on a calculator, right? So we can ask that agent, this AI agent, to solve some problems for us. So since these things happened in the last few years, it's really timely, right? So now AI became right forefront because it's because of the democratization of the usage of it, and we all feel comfortable using these agents. Oops, one more. Okay, so I also want to highlight that we're also in the middle, in terms of why now question, we're also in the middle of what I would consider what everybody refers to as fifth industrial revolution. So that first industrial revolution was, figuring out the machinery. That was 1780s. Then the electrification came 1870s, so 90 years after. 100 years after, we started talking about, computer and automation. That was the third revolution. And then there was this IoT devices, cyber-physical, so data collection from sensor. That was Industry 4.0. And now we are in the middle of Industry 5.0, where, human and cyber-physical systems are working together through these AI agents. And I want to also highlight that, the first two industrial revolutions, or first three, were like 100-year time cycle. Now we're seeing 20-year time cycle for every new kind of approach that will revolutionize the industry. So, which also means that we're in the middle of probably a continuous change, disruptive technology development as we go forward. So where are we in the AEC and FM? Now and future, if I look at the highest level, we have started seeing in companies using generative AI for proposal writing, reports, maybe creating initial schedules in their construction, maybe even using that as a way to do some initial design explorations. There are companies, there's a lot of concern, of course, feeding your knowledge to a publicly available ChatGPT-like system, and then you lose your knowledge, right? The IP concerns, but there are companies who are implementing their own systems, or they use the AI, but they do it with their own data sets within the company's boundaries. So it's not training for the whole world, but for their own operations. There have been quite a lot of success on vision algorithms. So any kind of image classification. I have done quite a bit of work in that area as well. I'm not including that in my talk today, but happy to chat about it if you have any questions. Images, laser scan data, 360 images, thermal images, those are now easier to process and turn those pixels into actionable information, because there are a lot of labeled data sets out there and it's easy to process. We are seeing, and that's where my focus is going to be on this talk, is and we're seeing some interesting implementations of diagnosis, like something is not just saying something is wrong, this is wrong, and prognosis, what does that mean when this component is going to fail, and then get into a more predictive and prescriptive maintenance or assistance as we go forward. So I'll talk a little bit about that in the next few slides. And I do think that we are maybe already there, but that we are getting into these autonomous agents where we harness the power of digital twins and AI. And I'll talk about digital twins as I go forward and why I think these two combination is needed for our industry. Maybe before I do that, just to give you a sense, what we're doing in this continuously changing world is that in our department, we take a different approach for our education, civil and environmental education. We are educating our students thinking about these concepts, data, AI, cyber physical systems, systems of systems thinking, with an eye towards, resilience engineering. So just want to highlight that the implications are also in the way that we educate our students, the way we do our research. When you look at our department, you'll see that it's fairly untraditional. You are not seeing, for example, construction management or structures in our programmatic areas. We are organized around 4 groups: climate resilient environmental systems and technologies, intelligent engineered systems and society, and that's where you're going to see a lot of digital twin and AI work, mechanics, chemistry and materials, and sustainable energy and transportation systems. And then I will also want to highlight that, some of the things that I'm going to talk is embedded already in our curriculum in terms of AI engineering and policy for climate mitigation, for example, or autonomous buildings, foundations of digital twins. These are the courses that civil and environmental engineer students take in our department. And finally, we also do that because of the need for continuous learning. We do want to support the need for upskilling. So we do have an online certificate for practitioners who work in the field who want to upskill in terms of their knowledge in digital twins and AI. And we do that too, to increase our impact in terms of how we share the knowledge in this domain. So coming back to this, right? So I keep saying autonomy, we're heading towards autonomy. So one might ask, where are we in this spectrum of, we have a lot of smart buildings, and where are we from smart buildings to autonomous buildings? So I'm going to compare our industry to cars, because cars achieved autonomy, right? So in a car, a medium-sized sedan has 400 sensors. So it is a good cyber physical system, right? It has all these sensors on it. Then we treat these cars as, cyber physical systems or these computer systems. So when you take your car to your dealer or a service place, they don't just open up the hood and start unscrewing stuff. They typically put an intelligent diagnostic tool. They hook up a computer and see what's going on, and from that they fix it. And then as we said, the autonomous cars are there. We are starting various versions of autonomy in the car driving space. In buildings, let's say 60,000 square foot newly constructed building typically can generate 21,000 data points just on building automation system. And clearly, it's also a great cyber physical system where it has all these sensors data on it. But then we do not treat typically these buildings as giant computers. When it comes to diagnosis and maintenance, we go back to our way of, taking up a hammer and try to fix things. And autonomous buildings, it's not clear where we are in that space. Maybe we're getting close to it, but it's not a reality right now as we have in autonomous cars. So then one might wonder why cars made that and not the buildings. And oh, sorry, before I go into that, just that operation, just that manual diagnostics, right? Just being some not treating the buildings as these giant computers and doing sophisticated, computer-based diagnostics. If we do the manual, we miss, failures in our HVAC systems. And that is alone for a 50,000 square foot building, the undiagnosed HVAC failures are about 20,000 annual energy waste. So this is based on I believe DOE numbers or ASHRAE numbers that we have looked at as reference. So you might say, okay, why do we even need autonomy, right? The reason is that this is a fairly simple example, right? So on the left-hand side, we have we do have a damper and a supply fan providing air to an office or a room. On the left-hand side, damper is 100% open and airflow is certain, volume coming to the room. And in that case, the supply fan has a speed of 37%, right? These dampers tend to get stuck. So if the damper gets stuck to 40%, the supply fan is still providing the same amount of air to the room, but now the speed is 92%, right? It's working much harder to provide the same air to the room. This will not typically, this would be difficult to identify as a failure because the occupants won't feel anything. So you won't receive a complaint from occupants saying that I'm feeling too hot, too cold, I'm feeling stuffy, right? None of these are happening because it's behaving, in terms of the occupant comfort, it's the same. But under the hood, right, you are basically losing twice as much energy because of this fairly simple and highly occurring fault that happens without you actively looking at it, right? So if, of course, this can be diagnosed if you have dedicated folks that look at this 20,000 data points on a daily basis and see what the issues might be. But given everybody's time frames, that's probably not realistic. But if you put an AI agent there, right, an agent that continuously analyzes the data, it becomes your apprentice to help you identify these kind of faults so that you can act on them. And as a result, you won't waste energy, right? So I'm just talking about elimination of wasted energy. I'm not even talking about improving the energy, right? So it's just minimizing the waste of energy. So this to me is an example of why we need these autonomous agents embedded in our buildings to continually look for things in a reliable way. So going back to the car versus buildings, right? So why buildings didn't come to the level of cars in terms of sophistication, in terms of autonomy. There are certain aspects that are challenging in our domain, right? So first of all, each building is unique. We all know that each of them has very complex control logic implementations that manage these interdependent building systems. And even in the same building, the same components behave very differently. So here's, for example, what a control logic implementation of this fairly simple HU is. And it's kind of a spaghetti of things referring to each other. So it's difficult to, and all of these are typically tailored to different buildings. It becomes challenging to come up with one solution that will work for all buildings. The second issue I mentioned that is that the power of these early versions, the machine learning, is learn from past and repeat, right? And hopefully in a scalable way for maybe multiple components in the same buildings or multiple components in all buildings, right? If you have that type of an analysis, that's great. So we tried that for rooftop units for rooftop units of a building. There were 6 rooftop units in this particular building. We said, okay, we're going to sit down and label the data for one rooftop unit. The AI system will learn from it in terms of the faults that are existing. And now we're going to use that model then, the learned model, and apply it to different rooftop units. And we thought that, if everything came as 90% and above, then life would have been easy. And we said, okay, just use anything on any machine learning algorithm and it's going to work fine. But as you can see, it learns from the thing that it learns from the first rooftop unit. It learns and it predicts well, but it doesn't transfer that knowledge. That knowledge is not easily transferable to other rooftop units. So you're not achieving the same accuracy on fault detection for the other units. And the reason for that is that each of these units feed into different parts of the building. Even though it's the same manufacturer, it's the same building, it's because the context under which it works is different. And as a result, there are these different nuances that makes the transfer of knowledge from one unit to another challenging. And then, the other aspect is, okay, let's say we learned everything for this point in time. As you also know that, changes occur all the time throughout the building's life cycle, right? So I remember when we moved into a new building several years ago, this is not it, in a different building. First thing we did is we turned the conference rooms to office spaces, office space to conference room, right? As soon as you enter a building, things start changing. And the life cycle of our buildings are, 50, 60 years. In this building that I'm in is 120 something years old. The change is going to occur, right? And with that change, the learning that AI did in the first version is not going to be transferable for the upcoming changes. So I always make the joke that, think about it is you got a sedan and you turned it into an SUV and back to a sedan, then of course the autonomy in that system wouldn't work either. But we don't do that to cars, but we do that to buildings, right? So that makes then autonomy that is scalable, that is robust throughout the life cycle of a building to be a bit more challenging. And that's part of also why the owners and users are deeply involved on what the building does. Typically, they sometimes do, but not always, that owners of cars don't, put plasters on sensors on the cars. But then we do that if we don't like the light sensors, right? Then we put stuff on it so that it doesn't turn on and off for us. So the, occupants also have a very active role in terms of how the building behaves. And the faults and issues, because we are part of the systems of systems, very complex systems, it is very challenging to there might be some repeated faults. That's fine, then we can learn from it, but it's difficult to capture all possible faults and label them so that an AI system, a machine learning based AI system, learn from it and help us use it. So there's also some labeling problem. So with that, we do think that context matters, right? So it's not just the algorithm that we can get black box algorithm and pop it into the building domain and it's going to work. We got to tailor that to the context of each building. And for that, it's great that, we have all these different data sources in buildings. And we can use that to create what is called digital twin of a building. laser scans, building information models, building automation systems, work orders. We can fuse all of that data. We can run simulation models on our buildings. We can do physics-based simulations or database simulations. We can even put rules. Now we have a portfolio of approaches that takes advantage of the digital twin of a building to come up with much more reliable and robust kind of diagnostic approaches. So autonomy in the built environment is, in any environment, the famous kind of loop for autonomy is what's called OODA loop. So you start with observe, orientate, decide, and act. Observe, and we believe that there should be a digital twin in the middle of this OODA loop to make it more reliable. So for the observe, there are lots of, we have made a lot of advancements, all these building automation systems help us, observe what is going on in our facilities. But then, what we're missing, and we do have some implementations in the industry, but not like 100% robust yet, is around intelligent diagnostics and root cause analysis, which is the orientate, decide, how do we prognose and say a component is going to fail and maybe eliminate the failure before it does, and do what if analysis. And then, if we are really talking about full automation, it's, these systems, how do they self-heal and self-optimize as they observe and understand there's an issue and act on it, right? So that's the full autonomy circle. So we have done, this is probably 15 years ago, we approached this from that perspective, HVAC, fault detection from that perspective, saying, how can we bring self-healing, self-management, some autonomy to the HVAC operations? At that time, my PhD students went and looked at all the literature of fault diagnostics, and there's a lot of work in that space. And he came back and say, I don't understand. There are all these, algorithms. Why aren't they being used? And he approached it towards by saying, well, probably all of these algorithms need different types of information, and we need to bring them together to be able to run them. Hence, some of the early work around digital twins is how to bring all these heterogeneous data sources to be able to enable this, self-recognition, self-monitoring, self-configuration abilities for HVAC systems. That required, bringing all these heterogeneous data sources into one platform. And we utilize building information models as a way to overlay these data sources, at least to be able to give visual feedback to the facility operators in terms of where the issues might be, where the hot cold spots in the building is, where maybe work orders are done much more than other parts of the building. So at least visually, we can provide some situation awareness of where the issues might be in a facility. We have done work on, as I said, the image recognition. I'm going to skip it, but happy to answer any questions on that. So that work, the initial work on the HVAC diagnostics and integrating these data sources turned into this startup where basically there's no hardware development. So this is designed to provide prescriptive maintenance suggestions to facility operators based on faults that are being detected and diagnosed in HVAC system, and based on the energy waste that those faults lead to, so that it can prioritize, where the issues might be. So this is a completely, I would call it like an AI agent, right? It doesn't have any hardware component. It basically taps into a building automation system and using BACnet or other, standard protocols, gathers the data, creates time series, which is, a lot of people already does, not a big deal. I think the secret sauce is, which is based on our research from 10, 15 years ago, is this creation of this digital twin and utilization of this digital twin to be able to do prescriptive maintenance. So even in the creation of the digital twin, we use AI. As you might imagine, when you tap into a building automation system, you're getting thousands of data points with random names associated with it, and which sensor and where that is located needs to be figured out in a fast way to be able to utilize those sensor data in a digital twin environment. So one of our prior research looked at how you can use AI-based approaches to understand where the data is coming from and map it in a building, so that you can create the digital twin. Then once you have the digital twin, then there are already many, many algorithms out there, right? There are rule-based, there are simulations. We can run simulations for what if scenarios. We can have, data, machine learning approaches on it, and tailor, all of the suite of AI algorithms by using the digital twin of the building as the context to come up with reliable prescriptive maintenance, right? So that has been our research for decades, and that's what kind of transferred into this. So if you have a BIM, it's great. It's not a big, you don't need to have a BIM to create the digital twin. And in fact, I think most of the clients do not have a BIM. But if you have a BIM, then you can overlay the issues, HVAC related issues in your 3D model, and you can see the patterns of where spatially things might have been clustered in your facility. It's, as I said, it identifies it doesn't say, the sensor data is above a threshold, beep, there's a fault, right? Which is common. That's a rule-based system. But because it has the digital twin, it identifies the root cause. And because we can also do simulations and we have integration of different data sets, it also tells how much money you're wasting because of this fault. So bringing a much more transparency and actionable information for facility operators or energy managers to use to minimize the waste that comes from the HVAC systems. One of the issues with AI systems is that everybody says it's black box, right? So if you get this data and you're like, okay, cool, I see it says it has problems. Well, how do I believe in this? Tell me, show me a proof, right? So, and there has been, there are research and it continues, in terms of how you can come up with explainable AI solutions, like you can explain the results. So in this case, for example, somebody can click on any of the faults and it takes you where the data set and the time period and the relevant data where that fault was diagnosed. And you can look at it and you can agree or disagree, but you can see it brings a bit more explanation on why, the system identified this as a fault. It is, this type of a system can cover many, many different faults, hardware failures, bias sensors, leaky valves, which we see quite a bit in many facilities, fans, as well as software failures, conflicting control parameters, fixed schedule control. We do see, we saw some examples of this, VAVs are kind of acting as CAVs and things like that. So it identifies a wide spectrum of faults and diagnose, not just identifies the faults, but diagnose it and does the root cause analysis. Some example from different parts of the US, different weather conditions. If you utilize a system like this, they have seen over the years, over a year time period, in I think a year or a year and a half time period, monthly acting on the falls, they have seen energy savings because they're no longer wasting. And as you can see, we are not using any weather data in that system, but the system adapts to different conditions, right? East Coast weather versus Southwest weather. We have hospitals. We also have museums as the client. Their hospitals might be temperature, museums care about humidity, that the system, because it utilizes the digital twin combined with AI, it adapts. And that's why I think that combination is an important combination. At least in our research, that's what we believe, that will make things much more robust and adaptable. ACT, we had a couple students start getting into how buildings become an autonomous partner of grid. So getting into grid interactive commercial buildings and not having a single equation, black box equation for all buildings, but rather bringing some transparency on what the demand flexibility of a building might be by characterizing the VAV bulk sizes in this case for specific buildings. Through that, we have improved the prediction error on the demand flexibility much better. Then in that case, then the buildings become a much more reliable active participant of the grid. I know we're running out of time, so I covered, many things that I wanted to cover in terms of how the AI and digital twin might work. So I'm going to skip these. I want to finish maybe by saying, well, we are doing autonomy, but as we do the autonomy, we want to be responsible, right? As we use these AI, we want to make sure that it's done in a responsible way. So that, and we got to understand the limitations, right? So one thing I've said is that AI, especially the machine learning algorithms, are as good as the data that you feed into them. And this was on the left, you'll see a research that is done in our department where the researchers are using privacy preserving sensors, which is the depth sensor. So you don't know to figure out how many people are going in a space and outside of a space so that they can adjust the HVAC controls accordingly. As you can see, I can't figure out visually who this person is. So that's why it's privacy preserving, which is very important to be a responsible AI. But one thing that we have realized is in this particular depth sensor, it might not be good, and the corresponding algorithms, it wasn't good in detecting all people, right? If you have a certain body shape or certain hair, it was missing to count you. So which means that the data that you're feeding to your AI system will be biased. And that's also a lot of conversation around that space. Some of the data that is collected are biased because not every building has building automation systems, etc. So as you're using these AI systems, be cognizant on what data you're using to train those systems. And with that, you might create some biased results that is tailored to maybe certain group of people or certain types of buildings, etc. And similarly, we need to think about, cyber physical security implications of, as we bring autonomy to our built environment, what does that mean for cyber physical security? And autonomy as we bring them should be used by all audiences. This is a tweet actually close to our campus, not on our campus, of a kind of a robot kind of trapping a wheelchair person as the robot was delivering things on Forbes Avenue on the streets, right? So it's good that we are providing easy access to food or medicine or things like that through robots, but we also need to be cognizant that they got to interact with a variety of population as they work. So in conclusion, we do need to transform. I do think that we need to transform the way we manage our facilities. AI is an awesome tool towards that, and gets us close to, having an autonomous system that would empower human to make the right decisions. And of course, as we all work, especially in academia, in developing these autonomous systems, being responsible and developing responsible autonomy is going to be the key. So with that, I'm going to stop so we can have at least some time to chat.
All right. Thank you so much, Virtue. That was great. Any questions? Because I also have a couple that people have sent over to me. So I'm going to start with the audience to see if there's any questions out there.
Hi,
Okay.
it's Russ. Can you hear me?
Hi, Russ. Yes, I can hear you.
Okay, sorry guys, I was having audio issues earlier, so I couldn't talk, but think I got those resolved. I understand I understand in the presentation the idea of the reasonable autonomy or responsible autonomy. That feels like a suggestive or maybe an objective term. Is there, and I don't even know how to ask this, is there a group or a governing body that's going to establish what's reasonable and what's not reasonable? And, obviously we have to think of the handicapped. We have to think about different groups, different ethnicities, different, like there's just lots and lots of things to consider. Is there any governing body that's going to decide, okay, this is the standardization of how we're going to be responsible with our autonomy?
Very good question. And to be honest with you, I don't know the answer. What I know is that a few years ago, when this whole ChatGPT kind of went about, there were a lot of letters to figure out, is this going too fast for standard agencies to be able to come up with, as you suggested, metrics that says this is how a responsible AI is defined, and I'm going to feed your system into this test bed with these metrics, and if it passes, then it's responsible, right? So, I at least a couple years ago, the governing bodies were kind of lagging behind in defining this. I don't know the current status right now. I have not heard, but don't quote me. I don't know. But certainly there have been quite a bit of talks and actions around it. I don't know whether, these governing bodies caught up with the technology fast enough to be able to come up with the metrics yet. I don't know.
Thank you so much.
Well, I do have a question. It was sent to me. So, some of our members are more on a basic level for AI. So the question is if a company or a building owner in Dallas wants to start leveraging AI for sustainability, what's the best first step? Since you're the expert here, what would be kind of the first step to doing this? And, the second part of that question is, if they do use these tools or platforms for their buildings, is there any major infrastructure U-Hauls that need to be added? I think that those were the two questions that I had a couple of people ask.
So the second one is easier, so I'll start with that one.
Okay.
Easier for me to answer. Maybe the answer is it depends. The example that I show you, the Lean FM technologies, for example, does not require any additional hardware or anything. It requires for the system to tap into your building automation system, and it can happen in many different ways. It can be deployed in your firewall, outside of your firewall. And this is not the only system who does that. There are other diagnostics approaches that do not, software systems that do not require additional hardware, and they can tap into your system. Hopefully, it also doesn't require any additional training. You have seen most of these systems have fairly straightforward user interfaces. Maybe in the near future, we're going to see, maybe you're not even going to have a user interface. You're going to have kind of a voice-based interaction through like a ChatGPT environment with these systems as well. So I think the commitment in terms of training, or do I need to get hardware, that part, I think it's not need, they are not needed. But also depends on, there are also other fault detection and diagnostic systems out there that might require hardware. So I can't make a categorical statement, but there are systems that they won't need. First question is tough, and I don't have a good pathway, right? So what I would suggest, so there are a couple things that I'm going to suggest. So one is figure out, think about your most hairy problem, right? So if a spreadsheet can solve your problem, you don't need AI. Do not use AI. It's an overkill. You don't need it. But think about, something that, either requires a lot of attention, a lot of data ingestion. So AI is also do require, especially the current versions of AI require data. So if you don't have a lot of data available, probably that's not a good first step to, first decision to use AI to support that decision. So think about a data-rich environment where you are struggling to come up with an answer, or where your people don't have time. If they had time to look at all these data sets, of course, they could have come up with, let's say, these faults that I have mentioned, but they don't have time, kind of identify the pain points. So I would actually start using the AI in an environment like that. And whatever that is, I'm sure there are a ton of solutions out there that you can utilize to start evaluating the value of AI. Having said that, right, so now I'm going to wear my university hat on, and I would say that, teaming up with universities and researchers will also be a good approach in the space, because, you're in a learning mode. The problem might be too complicated for a single system out there to solve. Having researchers kind of evaluate different algorithms and come up with a pathway might also be valuable as you first kind of get into utilization of AI.
Okay, great. Another question is that what are some of the things that AI can do to help the Dallas 2030 district meet our goals, or at least get one step closer? And maybe the focus might be benchmarking. Is there a way that AI can help us in benchmarking? Because I know that I sent over some materials before the session about, what our goals are, which is to reduce our energy, water, and transportation consumption by 50% by 2030. And as you know, we're about less than 5 years away from that. So every year we do our annual impact report, and we have benchmarking in there to see how close we are to those 2030 goals. So I was just wondering, is there something out there that we could be using to make this a little easier to understand, or to help us get one step closer to our 2030 goals? I don't know if you have the answer to that, or any thoughts or suggestions on that question.
That's also a very good question. As you were asking, my mind was going in a couple places. So one is like there are systems, as I like the ones that I mentioned, that creates the low-hanging fruits, right? So if you can eliminate the waste, you're already saving, 10% right there, right now, and without really committing changing your LED, changing your lights, or changing your exterior enclosure and things like that, right? So there are these low-hanging fruits that AI can help in identifying by just eliminating the waste that you might have. So that's one direction that my mind was going. The other direction that my mind was going when you mentioned benchmark was, so nowadays, ChatGPT can do a research for you, right? So if you are sharing your lessons learned in a way, you can feed that into the new version of ChatGPT, and it can actually come up with some strategies that is kind of shared across different institutions, maybe even across different districts, to come up with maybe best practices, learn from the benchmark in a more autonomous way. Is there a tool out there? I don't know, and I'm totally speculating around utilization of ChatGPT, but I've used it for, can you do a search on this type of activity on XYZ, and it actually creates fairly good comparison results that are in a fast way that you can, again, it's up to you. You need to figure out whether those are the right things to do, but at least it synthesizes the knowledge for you to act on.
And I don't know if this is a question that you can answer also. I had somebody also reach out to me asking a question about data and where it goes. Like if we put in information that's kind of confidential, let's say we wanted to benchmark a building, but at the district level, I mean, at the Dallas 2030 district, everything is at a district level. So nobody knows which building has what Energy Star rating. And so we want to make sure that we keep everything confidential. So when you do look at our annual impact report, it is more about how is Dallas doing as a whole. So I had someone ask a question that if we put that data in, where does it go and who gets to see it? And, is it stored in a little box somewhere where somebody can pull that out? I wasn't sure. I didn't have the answer to that question. So I thought maybe you might.
Well, so if you feed it to the general ChatGPT environment, right? So it's going to go to the general public usage. It is, and if you're training the system towards that, it's going to be utilized by everybody. And hence, what we are seeing is the companies who are using these kind of generative AI approaches, they get the AI engine from companies that generate it, but then they feed their own data, and that data and the training happens within that company's perimeters, and you're not basically training the one that is available to the whole wide world. You're training your own AI agent to help with the decisions.
Okay, that makes sense. And we look at everything at the district on two levels, from a membership level, and then how can we help those members get to that next level? So, anything that you would suggest using, and I'm not saying like a specific kind, a company for AI, but like a specific type of AI that we should be looking at or kind of leaning towards. All of this is fairly new to all of us. I know that, you are much more experienced. So we would love to kind of be pushed into a direction where we can at least start somewhere because, everything, there's just so much information and it's so overwhelming out there. You turn on CNBC, you turn on anything and it's all about AI. And, I don't know and members don't know which direction to kind of push towards. So thought that might be something you can kind of guide us through and say, you can also give me a very broad answer or a very specific one, but, a good starting point for us to be push towards to take a look at that. And I guess that kind of rolls into the first question that we had, but it's just a different kind of approach to it.
Yeah. So, I mean, I think the easiest first step is if you haven't used any of these generative AI platforms, I suggest you use it just to test. And you're going to see, right, there are really powerful aspects of it and there are limitations of it, right? So it gives general broad brush of good stuff, but then sometimes the facts are not correct. So just to, start playing around that, it will enable you all without needing to learn any algorithm to understand the capabilities of the generative AI. To me, that's that's easy. It's free. It's fun. So you kind of start playing around with it. You can create a whole slide deck through AI. You can create arts. You can say, I want this theme in Picasso way, and it's really fun. You can spend hours just to kind of play around and understand the capabilities would be my suggestion on the first step. Then you say, wow, this is interesting. But then she also talked about, these being able to do diagnosis, the machine learning. I want to get a bit more, I want to use those to be able to analyze my data sets and things like that, then I would suggest there's quite a bit of, we're not the only one. Lots of universities and also within our universities, other departments also providing these, AI digital twin courses, and they are designed for industry folks. So the expectation is that you're not going to come with a big programming background. It's a way for you to kind of see, let's say, computer vision based approaches or other, time series analysis approaches to truly understand what other ways that you can use AI for different data sets. So that would be probably my second level suggestion. If you want to go a deeper understanding, if you want to be an expert, right? I want to develop my AI system. You can also do that through that. There are also these certificates that are more now tailored around, got to understand the algorithm. I'm going to build something, and you can do that too.
Okay, great. And then I guess the last question is, and it's going to be more tailored around, we had this session. What does another session look like to you? What would be a next step for us to discuss? Because I feel like, you gave us just a wonderful foundation and then a little bit more than that. So where do you think we should be kind of going from this? And of course, I know this is just a suggestion, but since you know more than we do, you're our subject matter expert, I just thought I would ask you to get some thoughts and ideas on how we should be pushing forward when we are, doing another session. Because, like you said in the beginning, that this is going to be multiple series, multiple sessions, because you can't cover everything in one.
Yeah. I would say, I hope that this was good kind of foundation to kind of lays at least the terms and what an AI might look like. Maybe deeper dive in different use cases might be a good way to go forward. It depends on, the district's priorities, a use case on energy efficiency, a use case on the transportation maybe might be a way to have a kind of deeper dive, specific implementations and how things work in that space might be a good approach. The other approach is to continue also to build the foundation. Going back to the earlier question around, maybe bring somebody on AI and ethics and responsible AI side of things too.
That's a wonderful thought. Yeah, no, definitely. Or maybe we can incorporate that into the session as well as part of it. I think that that's a really good idea. And, I wanted to thank you for taking the time to do this session. We're trying to find our sweet spot. We have the Goldilocks issue here. Is it too much? Is it too little? Where do we want to be with AI? So we really, really appreciate you laying all of this information out for us and being so transparent and being so friendly about things and not making it so formal. I know a lot of people are, it's not, I guess, scared of AI, but they just don't know enough about it to be able to push forward. So we do appreciate it here at the district. Thank you so much. And thank you for everyone who attended. I know that there are a few folks, well, a lot of folks that weren't able to attend. There's so many things going on for Earth Month. But we've recorded this, so it's going to be getting a lot of views because it's a very interesting and very hot topic right now. So, Dr. Birchie, thank you so much. We appreciate it, and we appreciate everything you do for us.
Thank you. Thank you. Bye.
Thank you.
Bye.